Okay, so here is the interesting case which I want to bring up. Okay, so this is very close to me because I have been working with my technical team with they have been struggling and all. So my interest which has come up in this one was the BusyBox thing. Okay, so which I am about to talk about. But again, I will also tell you like where we had the problem and what kind of solutions we were trying to implement and all. And I think you can take it from there. Okay, for your organization and all. Okay. Okay, so let's begin, and it will be mostly on the theory part. Actually, I'm more practical guy. So since we are doing webinar, and I don't know the way you people may be reacting on that one, so that's where it will be more on the theory part. Yeah, but if you have any questions and all, you can keep posting, but keep them mostly for the busy box thing because if you divert me, I get diverted very soon. Okay, fine. Okay, guys, welcome. And yes, so we are talking about the busy box thing. Okay, so let me first get into the challenges and all which we were facing. Um, when we are deploying on the Kubernetes environment, it is mostly the containers which we deploy. And when we talk about the container, we look into very small sizes, and we expect that the containers should come up easily and they should be start serving. Okay, they can delay in the service because maybe some application may still not be ready, but at least they should start serving and they should not get stuck. Okay, so in my experience what I've seen is many people have been starting the Kubernetes pod and it gets stuck or it is like failed, and then they keep debugging the things and all. So I was curiously why exactly it is happening. Okay, so the main thing, as I told you, we are into data engineering and all. So the two of the products which I we were talking about, the Apache Superset, which connects to various data sources to bring up the dashboard and all. It has like Flask, Node.js, DB backend. Then you have a Trino, you have Super Star Rocks behind the scene. Then there is another tool which we use, that is Airflow for orchestration. So where you run the complete pipeline, you have a complete DAG over there. Again, all the pipelines which we deploy are DAGs are written in Python, but they also serve your PySpark files and even Java programs and all. You can schedule any kind of job over there. Okay. So these were the two main containers where I saw people were getting stuck and all, and I had to pitch in over there and you understand what exactly the problem is. The main thing which I noticed, the pods were not starting. Okay, as they said, okay, I have uploaded the pod, it is coming up. Then I call them back again. They say still running and all. I was curious, like why it is happening, because when we talk about the microservices, when we talk about the pod, I want it to be immediately started. Okay? And now the thing which we say is superset. Okay, why it is stucking. Okay, so that's where I tried to debug the things, and then we saw that okay, it is like Flask and it is Node.js. As I already told you, it is for visualization dashboard and all. Okay, now we connect to the Trino and Starrocks and then LDAP authentication. So these required some dependencies. Okay, like Trino was not having the inbuilt module installed in that one. So developers were doing the pip install inside the pod, and then same thing for the Star Rocks. When they were doing for the LDAP, again they had to do some apt get install and all some Linux packages and all. This whole thing takes its own time. Okay, and again whenever you are doing any installation in the pod itself, yeah, it will be slowing down the things and all. So that is where I was like, why you are actually installing over there? Okay, why can't we do the other way? Okay, so yeah, you guys can tell me like what are the other ways you can give me a hint. Okay, how we can make it faster. Okay, if you have faced such kind of issue, because I think this is a general issue which every organization faces and all. Okay, so let's talk about the other one, which was the Airflow. Same story repeats over there. And as I said, it is for orchestration. I want all my DAGs to be running. The complete pipeline should be running. Now this is stuck. Okay, so I when they ran on the Docker, they said everything is fine. We had the demo and all, but when they put it on Kubernetes, yeah, these were the stuck. So what were the steps they were taking on the Docker? Same thing. They were doing all pip install, everything and all, and then some or the other way they brought it up. Now when we use the same container, we don't see the result over there. Okay, so that is where the challenge, and the same story repeats over here. You have a Java dependencies, you have Python dependencies, you have other things which does not bring up the Airflow. Again, Airflow also has a DB to set up. Okay, when it starts initially, it will set up a DB. You need to do the DB init, you need to do DB migration, and after that it will start. Okay, so all these stories are behind the scene. So now I was looking into these things. What is that I can do with them? Okay, because like most people who come with the Kubernetes environment, I think it is just somewhere around like 5 years or so. So you don't have like much experienced people. Even we had struggled with getting the right people, getting all the things onboarded with them. So what my teams were doing was whatever they were trying to bring up with Docker, they were just trying to bring up the same thing on the Kubernetes, okay, because we have the containers and all. So when I brought them all together, I said, okay, so this is my requirement. Okay, like I don't need faster pod is initialization. Okay, few runtime errors or missing packages and all. Okay, and I also want that you install. Okay, you can put the pip install. You can add the Java file. You can add any jar file and all. But I don't want like pod to be stuck over there. Okay, can we find the alternative way? Yeah, so I think you guys can also update me if you have faced similar issue and you have tried some or the other way. Okay, so I would be ready interested to look into those cases. Okay, so here comes the big busy box thing. Okay, so first thing why I came up with this session is like last time I met with at Zop.dev the team and all. I was talking about the OS and all. I was talking about how we improved the booting up the Windows machines and all on those days. Okay, so thought, okay, why don't I speak on this one? Okay, because this was the case which was we were following, and that's where I have come up with this session on the BusyBox thing. Okay, BusyBox is like very lightweight. Okay, it is written in C. It is like less than 1 MB. It combines all the Unix utilities and all. Okay, and it uses a base image, and also you can have your own image and on top of that BusyBox. Okay, if you guys understand that kernel space and user space, so BusyBox serves your user space issues over here. Okay, and I don't know if you guys have noticed, like even if you put in chat GPT to write some Kubernetes YAML for you, which you need to have some basic steps to be done, like you need to have what you call some create some directory structures, you need to create some owner some for some files and all. Okay, so you might have noticed, okay, if you have gone through those files and all, it pulls up the BusyBox image over there. Okay, so what BusyBox is, as I told you, it is having the core utilities. Okay, like in Linux you will have the file utilities like ls, cp, dd, text utilities like cat, less, tail, and head. There are many. Shell utilities are there, echo, true, yes. I don't know if you guys know all these commands and all. Okay, if you don't know, you can just ping me and you can ask me because I've been using all these things. Okay, so if you go to the Linux world, yeah, these core utilities are heavy. Okay, they are very big files and all, and there are also base images which come with the core utilities and all, though they are lightweight, but BusyBox comes with the minimal. Okay, and the advantage of BusyBox is all these utilities which you see comes in one binary. Okay, just one binary, and you can just use BusyBox space ls, and then you have the list of the files. Okay, you can say BusyBox space cat and the file name. It will show you the file. So whatever your cat command was doing, whatever your ls command was doing, can all be done by BusyBox. Okay, and it is very lightweight. As I told, it is just a small one binary. Okay, how this has been used in the most of the systems is you create a symlink. Okay, you create a symlink to ls using BusyBox. Okay, so you have a ls allies to BusyBox, you have a cat allies to BusyBox, and BusyBox internally will check. Okay, I don't know if you understand the positional parameter. The first parameter is the program name. If you say cat, then it will obviously show you the file. Okay, that's what the cat is supposed to do, and ls lists the files. Okay, so BusyBox takes the first parameter to identify the program, what user wants to execute. The rest of the parameters are taken care over there. So that is the advantage of the BusyBox. So it is coming with the lightweight. And if you understand, when I said we are trying to resolve some problems of dependencies and all, so I wanted to bring up a container, okay, which is outside of Airflow and Superset, which I talked about. Airflow and Superset, I don't want them to do the pip install. I don't want them to do the jar installation and all. Because in some cases, people were actually writing wget jar file in the pod itself. Again, which takes a longer, right? I don't expect it that you people should connect to internet and pull something when you are actually in the pod. Okay, so that's where I was looking into some utility, a smallest possible tool, and that's where BusyBox comes into picture. Okay. Okay. So uh, in Kubernetes, you can just put BusyBox and you can just start the shell over there. Okay. So I just give some commands. Okay. I will not be getting into all the commands and all. Okay. And you can see you can just write a init container. I don't know if you guys have explored. Yeah, you can just write a init container by which you can call the scripts. Okay, you can pass the command and all. Okay, and BusyBox also comes with the shell thing. Okay, so when yeah, how did I run? 1 minute. I think it jumped 1 minute. Jump to the other one. Why did it jump over there? It directly jumped to the last one. Okay, challenges we talked, superset we talked, core things and all we talked. Okay, this one I talked core utilities. Oh yeah. Okay, I think yes. Yeah, I kept it very short. Okay, okay. I think this image did it come? Okay, so that is the thing, and where is the other part? Okay, one part I missed. Okay, anyways, I think I missed that one in the presentation. Okay, I'll just explain you what exactly we did over here from the front set. Let me just go back. Okay, so what we did over here was like we have mounted all the dependencies we have kept in the outside the pods. Okay, so we have mounted the volumes. Okay, like for pip install, I created one folder. Okay, so that is like pip lib, and then for Java, I created one JDK folder. And for other utilities, there were another folders written. Okay, so these were all mounted externally. Okay, which were available in the pod. Okay, now I have written a what do you call BusyBox job. Okay, what it does is it will run the actual pip install over there. Okay, I'll just bring up the text pad where I've written all these things. Okay, so from there we were actually doing the installation. So installation was done outside the superset. Okay, so whatever Python lib you want to install, we were installing outside the pod. Okay, superset pod, and that is mounted in the superset. Okay, so now what you will do is when you want to refer some libraries, okay, you can do sysappend to that path, okay, of Python lib. And if you want to have a JDK, you can export with a JDK home to that path. And whatever the other configurations which I required inside the pod, okay, like DAG files and all, okay, so that was also mounted external. Okay, that was for the Airflow. So with this, we were giving the path which was externally mounted. Okay, so now say you want to add a new DAC file for the Airflow, you can just spawn a BusyBox instance. Okay, from which you can do any installation, any DAGs and all. Okay, Airflow you don't even have to stop. Okay, so this pod was always running. So if I have to add a new Java lib, yeah, I can easily add over there. And in my DAG, I will always be having that path which I need to append to the current Python path. So that's how my applications were able to run, and BusyBox saved our time. Okay, so that we don't touch the pod once it is running. So all everything is dynamically handled now. So with I showed you the init container. Yeah. So uh, this way we were actually installing in the pods. Okay, so here you were having the pip install command and all. Okay, so by which we were installing in the actual mounted path. Okay, so all pods were having a mounted path. Okay, those were being handled by the BusyBox. Okay, BusyBox again, they come up very fast. Okay, yeah, they may be installing late, but your actual service like Airflow or Superset, which has the web page and all, yeah, they were up and running. Okay, so you can see that they are not impacted over there. But when the DAGs runs, yeah, DAG may be throwing some error, but by the time you finish your BusyBox uploading some DAG files or some libraries over there, yeah, your DAG will be running smooth. Okay, so it was very seamlessly handled, and we did not had any much problem after using the BusyBox container over there. Taking the complete advantage of the lightweight containers with managing with the heavy containers. Okay, so all the heavy containers we made them very lightweight by removing all the dependencies from the pods and keeping them with BusyBox installation. Okay, so that is the things. Yeah. So how does the BusyBox help us? So it has made all the pods very lightweight. Okay, easy to have a scripts over there, and perfect for containerization. So if you come in the cloud, you might have faced lot of issues like this. So BusyBox is very good tool over there. Okay, where you can explore the things faster by integrating, as I told you, like faster to launch and easy to manage the environment. All the pip install were outside, so we never had a problem like anything is missing. You can just launch a BusyBox container and deploy it over there. So my developers, it was easy. Now whatever they want to do pip install, yeah, they can just put it in the requirement dot txt file and give it to us anytime. Yeah, my pod is there, which gets launched and which installs over there. Okay. Okay, guys. I think, yeah, I actually had more on the technical part, but I don't want to take all those things because I not sure about you guys. What do you call? Have been through those details or not? Yeah. But anyways, if you have questions, yeah, you can let me know on that part, so I can share the more insights on that one. Yeah, guys.
Yes, everyone, we're open for a Q&A, so please do drop in your questions in the chat box.
Okay. Um, oh, no questions. I think everybody understood very well. You.
So
Okay.
just there is one question regarding the PPT.
This I will share. Yeah, but this is like very basic. Okay, I did not put much of the things and all. Yeah, but anyways, I'll share the things and all. Yeah, you can take this PPT and you can start exploring the things. Uh, I think I told about the BusyBox. It is like very old project. Like it was actually written for Debian booting up. Okay, so in 1995 somewhere it was written. Okay, when they wanted to boot up the Debian, so Debian, the your Ubuntu system. Okay, which boots up. So they were earlier having the BusyBox over there. That's how they booted the system, and that's how it came into the market. And then there are many other tools also available like BusyBox. There is also Toybox, which was written by the same committer who has written BusyBox. He came out of this team and he has written his own Toybox over there. Toybox is not that popular, but again, it gives you less tools, and it has more open source things in that one. BusyBox has some is reusing some of the existing core utils as it is, but Toybox has written most of the new. And there is also GoBox. I have not explored that one. GoBox is the one which is written in complete Golang. And also Rust is also coming up with their own utilities. Yeah, those are the things. I wanted to put in this one, but yeah, I'll share this PPT. Okay. So Raki can share with the people who have registered and all. Yeah. But anytime you have any questions and all, you can come back and ask me on these things. Yeah. And please reply.
So that was an incredible session, Sanjeev. Thank you so much. Thank you so much, everybody. Thank you,
Okay.
Satyesh.
Sure. Thanks, Raki. Yeah. Thanks a lot. Yes.